So, good evening everyone. I'm happy to be at Java user group. And my talk is about API. So as you can see, it has a really long title. So I'll try to explain it. So what I will be trying to tell you. So we can start with the definition of the API. So API stands for Application Programming Interface and is a way for two or more computer programs to communicate with each other, right? So on a typical architecture, you have a piece of software running on a server machine and exposing an API interface, and then you have a piece of software running on a client, communicating with the interface over the network. So it refers to the machine-to-machine communication. And in my opinion, machine-to-machine communication is less challenging, I would say. I mean, it's not that tricky because computer programs are doing whatever they are programmed to do. The problem starts when developers building them start to communicate. So a provider and a consumer need to exchange about API usage, about connectivity, about coding, about lots of things to make the communication, machine-to-machine communication possible. And yeah, I mean, depending on the structure of the organization, whether consumer and provider are sitting in the same room, and depending on the mood, sometimes consumer and provider might happily communicate and smile, but sometimes depending on some challenges, on boundaries, and depending on how our organization makes our life, it might become more challenging. And during this talk today, I will be going through potential challenges, give some pain points, and see if we can improve that. Before moving further, let me introduce myself. So my name is Enis Spahi. I work as a consultant at OpenValue. We help our clients to build better software, and we also try to make them faster, improve their communication, and we are also active in community events. You would meet us in the conferences, and we like also to exchange knowledge. And we are also active in 4 countries. That includes our Munich and Düsseldorf chapters. And so I'm also sharing my contact details in case you want to stay in touch after this talk today. So feel free to write me an email, maybe connect on LinkedIn. I also shared my GitHub account, so you can check all the code samples from today, but also there are others. So in order to understand eventual challenges regarding the API communication, we might see the boundaries. So I said provider and consumer, right? So provider and consumer might be, sitting in the room and or might be members of the same organization. And in that case, this is most probably a private API because the API that we are developing is used privately inside the organization. And sometimes this might be easy, but depending on the complexity of the organization, it might be also challenging. And then we might be implementing an API for our partners, business partners. So let's say you are a payment service provider, and then your API is serving your consumers, which are merchants and which have shops, right? So in that case, you might not have communication directly between providers and consumers. The communication might be mediated or might be done through non-technical people which try to transfer the communication. And then public APIs are the APIs that we actually use at scale, right? So in case we are a geolocation service provider, or weather API, or I don't know, any public API you can think of, in that case, it might not be even possible to communicate like directly between consumers and providers. So in that case, you expect the communication to scale, maybe have self-service tools, maybe have proper API documentation that would serve your consumers. And I said there are challenges, but actually there are also some statistics which show the challenges, right? So recently I found this this survey published by Postman, so it gives interesting insights, right? So they published a study, and one of the statistics was the obstacles to consuming APIs, and it turns out that 50%, more than 50% of the consumers are having troubles due to lack of documentation, and some are having difficulty in discovering APIs. So again, API discovery is about finding out how to use the API, finding out information about connectivity, and so on and so forth. And actually the third one was lack of time, which is kind of hard to address, but maybe we can improve some things on our development process to improve it. So let's see. And then considering this, we might conclude that there might be some communication challenges, right? So this guy here is having troubles to understand the API, and actually it might become frustrated. But maybe we can start with very simple things, like maybe you might just try to speak the common language. For example, in my talk today, I as a provider of this talk, I'm not a native English speaker, but I'm speaking in English and communicating with you. And you as a consumer, maybe also not a native English speaker, are consuming what I'm telling and understanding, hopefully. And I guess the API is also about that, so we could start by forming a common language. And actually there are already some common and standard languages which can be used. So I assume most of you are maybe implementing REST APIs and using the OpenAPI specification. And if you are building message-driven APIs, then you might be using AsyncAPI, or maybe you might be considering after this talk. And then I don't know. There are other API technologies which are not used that much anymore, but there might be WSDL as the schema for SOAP APIs. They might be. I saw somebody laughing, so probably still using in production. So if you are using GraphQL, you have GraphQL schema. If you are using gRPC, anyway, gRPC is schema-based. And I will focus today mostly on OpenAPI and maybe a bit of AsyncAPI. But first, I would like to understand, so I assume many of you are familiar with OpenAPI, right? So anybody not familiar? So that means I can move faster. And anybody not familiar with AsyncAPI? So that's good, because then this is a new information for you. So OpenAPI Specification is the technology agnostic standard for the REST APIs, right? Formerly known as Swagger, but with the OpenAPI initiative taking it over, now with version 3 it's named OpenAPI. You can write it as JSON or YAML, or you can generate it. And then you have great tooling to generate code or to generate documentation. And because you can generate documentation, we can consider it as self-documenting. And if you want to find out the tools that are in your disposition, there is this nice website which shows all possible tools that you can see on top of OpenAPI specification. And if you are building a tool and sourcing it out, then you can also submit your tool there. And then OpenAPI specification has a grammar, which is easier than German grammar. And I mean, I can quickly move because OpenAPI is spec version. We have the metadata information in the title. We have the servers part, which gives connectivity. And we have the path section, which describes the endpoints and responses, HTTP methods, and so on and so forth. Then we have the component section, which is a JSON schema section, which declares the reusable objects. And these are usually the request or response payloads. So OpenAPI specification, this is something which is not very old, but already some time there. So again, like OpenAPI specification, this time it's a technology agnostic standard for the message-driven APIs. So if you are building services that exchange messages over Kafka, MQB, or anything that is message-driven, you could use AsyncAPI specification, even though it's not coupled or bound to any of them. It is written again as JSON or YAML. It can be generated if needed, and it is an inspiration from OpenAPI specification. So, meaning it comes from the fact that OpenAPI was successful, and the guys from AsyncAPI said, why not building something similar for the message-driven APIs? And that's how we have AsyncAPI. And again, there is a similar website which shares the tools that are in your disposition. So AsyncAPI has a very similar grammar, right? The spec version, the info with metadata, then you have the connectivity information under servers. So if you are using Kafka, you can define the protocol version and the protocol itself. And then channels, instead of paths, in comparison with OpenAPI specification, defines actually an abstraction for messaging, right? So the guys, when they designed the AsyncAPI specification, they called the message exchange as channels. So in this example, we can see two services exchanging ping and pong messages, right? So provider, for example, publishes a ping message over ping topic and subscribes to the pong message, which is sent back from the other service. So this is the idea of the channels in AsyncAPI specification. And the last part is about components. So here you declare the reusable objects and schema objects, and then you can use between various channels, across various channels. So now that we've standardized the languages for API interaction, now there is a possibility also to extend this, right? To apply it to our style of communication, right? So if we are implementing a REST API, then we could eventually publish an API specification. If we are building a message-driven API, we could eventually publish an AsyncAPI specification. Maybe we might leverage the specification to generate more human-readable forms of documentation, right? And serve it also for non-machine representations, but maybe serve non-technical people and so on. Then we might use some code generation tools, so both languages support code generation, and maybe speed up our development. And then there is also the community aspect of the standardized languages, because once we have standardized our way of communication, also the community comes with the tools, right? So we end up with lots of open source tools, but also commercial tools which we could use for that. So it sounds promising, right? But how do we get there, right? So what are the tools to achieve that communication framework that I just showed, or how does it apply to our development process? So this is the most important part, and in the following section, I will show a demo which is about cooking, right? And And we'll try to build that demo, that system in multiple development processes or multiple approaches. So I would start now with my demo, and yeah, show how it looks. Okay, you see my screen. It's really dark, but so. I have a web application which helps me to find out or to decide what should I eat tonight, right? Because I'm back from work. Sometimes I don't have the energy to research, to find out what should I eat. So why not a system to help me to do that? And now I have a solution which I don't use in production, but at home. And that helps me to decide faster and move on faster. So how the application works is so I have a screen where simply I could give any criteria. For example, I would search a recipe which has pumpkin in it, right? And then when I search, I end up with results, the suggestion that what are the recipes that I could cook. Or maybe I have been to the gym, I want something high protein, and I could search and see, like suggestion on what should I eat. Or maybe I don't have any idea, I would simply click the search button and I would have all the options, right? Yeah, I don't have too much, but yeah, it's extended. And this that I'm showing is the front end of my application, of my demo. I also have a backend. So a backend is a REST API, which has recipes endpoint, right? And yeah, by using my OpenAPI specification or the generated documentation which has tried out feature, I could interact with my API, and this is how it looks. So let's see how we can. What are the ways to build this API in various approaches, right? So this I already showed you. So code first. Code first is the development process where we initially focus on coding, and the coding results with an API specification, which is communicated to the consumer. And actually, API specification is generated with the help of a tool or a library, depending on the framework that we are using. And then once we communicate it to the consumer has the choice. He could use to generate its client from the specification, or there might be some developers which are not fan of code generation, so they might simply use the documentation part of it and code their clients. And at the end, they kind of follow a release cycle where API provider releases the application first, and then consumer should go next, right? So the advantages of this approach is that provider can focus initially on coding, right? And provider has the flexibility to change the API design because it didn't communicate the API first. There are also some drawbacks, right? So the communication with the consumer is kind of late. So you involve the consumer after you are releasing your API. And that is kind of a problem for the consumer, and that also doesn't enable development in parallel. Another drawback is that we need to add lots of annotations to our codes in order to enrich our documentation. So without losing too much time, I would go into my demo. So, yeah. So our code first example has two applications, right? Okay, so my code first example has two applications. One is the service, which implements the recipes API. And the other is the client, which consumes the recipes API to show the results in the front-end UI, right? So let's start from the service. So it's a Gradle project. This one, I could make it bigger. Yeah. So it's a Java Spring Boot application, which implements the Spring Boot starter web dependency, and that enables this, that makes this project a Spring MVC application. And I'm using the Spring Doc OpenAPI starter library to auto-configure my OpenAPI specification, right? So when I start the application, the Spring Doc's auto-configuration is hooked into Spring's context and discovers the REST implementation that is in the project, and kind of creates the API spec and creates also the documentation out of API spec. And yeah, with that I could also show the code, of course. Then when we check our application, I have the main class where I annotated it as Spring Boot application, right? This is standard, and then I already am starting to add annotations which enrich my specification with additional information. For example, in this case, I'm annotating my main class with metadata information about my API. And then my controller implementation is a typical Spring MVC REST controller. On top of it, I have annotations which would add some tagging on the generated API specification. This is my find recipe implementation, and it's a get endpoint. I'm also adding some annotations from Swagger to add some parts, to enrich some parts in the documentation. And then when I check the payload itself, you can see there are lots of annotations. And in my opinion, this kind of corrupts the business logic of the application, which is not that nice, but these are the drawbacks of API first. And then once I start my application, so I could follow the documentation here to start my server side. And then I can already see that an API documentation is generated. I could reach my Swagger URL, which is the API reference generated from the OpenAPI specification. So this approach of providing OpenAPI specification together with the application sometimes might work, but might not be the best way, because it might be that your production server or the server wherever you are running your application might not be accessible to the users or to the consumers. So maybe you need other ways to provide your OpenAPI specification. And then there is another constraint that whenever you host your OpenAPI specification together with your application, you always host your latest version of your API. So you might want to version it, right? So in my opinion, a better way is to be able to generate your OpenAPI specification and maybe publish it as an artifact on your artifact repository, or maybe simply exchange the generated file and hook that into your continuous integration. And I'll show you how you can achieve that. So I'm going back to my code first implementation. So I have my Spring Doc, which is the library that generates my OpenAPI specification. That also provides a Gradle plugin that helps you to generate it without even running the application. So you would simply trigger this task from the plugin itself, and that will generate the OpenAPI specification and put it under your build folder. So that would be target folder if you are using Maven. So now that we've generated the specification, we are ready to build our client. Right, so let's see how our client looks like. So the client is again a Java Spring Boot application, which uses again a Spring Boot starter web to configure the application as a Spring MVC application. Then I'm using Timeleaf as the template engine to generate some HTMLs and to show them in my application. And also I'm using a tool called OpenAPI Generator. So probably you are familiar with it. So the OpenAPI Generator is actually originally a CLI-based tool which helps you to generate code from your OpenAPI specification. It has lots of support for various kind of generators. In this case, I'm using Java, and my setup is so I'm referring the input specification, which is the generated one. Then I'm defining where my generated code should be created. I'm defining the package structure. If I want, I would configure some suffix for my generated classes. And then I have the choice to decide which library or which API client I want to use. So recently Java has a really nice API client. So in this case, I'm using the native API client of Java. And yeah, so I have also other things like, do I want to use the Jakarta namespace or do I want to use the Javax namespace? But these are small details. And yeah, so I could run this task explicitly, but I don't need to do that. It's anyway hooked to my compiled Java lifecycle. So in fact, whenever you compile your code, it will regenerate the classes. And it is important to generate your code from the specification each time your compilation is running. In that case, you could keep your code up to date, and you don't end up like generating the code once and then, you know, maybe having the issues of having out-to-date code and so on. And yeah, so if we check how things look, so I have my application, right, which is a standard main class of a Spring Boot application. I have my controller, which handles the requests coming from my front-end UI, right? So if I press the search button, then my request would be handled in this handle search method, where I have an optional title, ingredient, or in nutrition facts arguments, which could be used for searching it through my generated API. And if I want to look through the generated API, then we could go and observe it. So, I mean, this is the code which is under the generated folder. So we can observe there are model classes and invoker, and this API client, for example, has the low-level API client, which uses the client from the Java library. So yeah, this was the API first, right? So let me, I mean, I didn't run the client. I could run my client and then show that we've achieved our API, which just I showed to you, and this was the result of the code first approach. Yeah. So now I would stop my deployed application and prepare it for the next demo. Going back to my presentation wrap up. So we started with coding. We generated a specification, and then consumer used the specification to generate the codes. Yeah, that was pretty much it. Our second approach is API first. So API first kind of prioritizes the API design over implementation, right? So everything starts from the API design. In this case, we don't generate the specification, but instead implement the OpenAPI as a JSON or YAML file. Any IDE or any other tools that is capable of rendering the specification might be helpful for you. And once we are generated, then the specification is communicated to the consumer, and then consumer or provider can work in parallel, can work in parallel, but they need to take care of one thing. So still the consumer needs to be released after API provider, right? And if we check the advantages of it, so it provides the early communication with the consumer, so you involve really early the consumer to the process really early, right? For example, in my client project, we do the communication of the API specification as a sign-off meeting, where we agree on the API changes, and then everyone is happy and we are good to go, and consumer can start the implementation, or API can start its implementation either in parallel or in any order, actually. Then most of the time in API first, the documentation is thought ahead, and as I said, you develop in parallel. Then there are also some drawbacks, right? So you have less flexibility to change the API design, because you communicated your specification quite early, and the consumer was relying on this specification that you created. In that case, you might need to repeat the process and go through the revision again. And because of that, sometimes this process might feel like a bureaucratic process, and sometimes might not be in the favor of a provider. So now I would show the quick demo. Okay, I think this time it worked. So as I said, so when we start with the API development, we always start from the OpenAPI specification, right? So in this case, I have my YAML file, right? So this is my specification, and I could work in a way that I split my screen to the left and right, and I change my API specification. So the right side is generated, and it already gives the overview before you actually communicate the specification. And as we are now in the process of being able to build in parallel, now it doesn't matter whether the client or the service starts first. So in this case, I would start with the client, right? Again, observing our setup, we have a Java Spring Boot application. We are again using the generated client. So we are pretty much having the same process, but this time we kind of took the process for the client a bit earlier, so client could already start implementation earlier. The only drawback is that we don't have a running service, so we cannot test it, right? So if we are doing an integration test, that could not work for our use case. So in order to solve that, what we can do is maybe mock the the server side, and that could bring us some, some times to move on early. But in the end, if you need to test things that are working together, you might need to run an integration test, which involves once both services are available. And then we have the service part, right? So we have Java Spring Boot application, so very similar to the previous example. We are using Spring Boot Starter Web again, right? But this time we are generating the server side also. As generator, we are using Spring. OpenAPI generator provides a nice Spring generator to be able to generate server side. We are referencing the recipes API. We are putting the generated code to our generated folder. We are defining the API package. Our library is Spring Boot. And there are a couple of configuration, but the most important one for us is the delegate pattern, because it provides some nice way to implement less code. So now in a while I'll show what delegate pattern brings. Let's check our code. So the main class is a Spring Boot application. We are kind of tuning the component scan so that Spring Boot could discover the generated code. And this is most of the time required. Then we could look into our controller. As you can see now, the controller implementation doesn't have any Spring MVC annotation. So it's Spring MVC free. And this is because the generated code already implements the Spring MVC annotations. And instead, it delegates the request handling to a delegate interface, which is implemented by ourselves. So in our case, we are kind of injecting our delegate implementation into generated code so that the requests are handled by my code. So it is, in my opinion, a nice separation. And we are, in that case, we could start our application and see that things work as expected. So I'll run my service. I'll run my client. And then I have my recipes web application, which is a result of the API first process. Let me now stop the application so that I could prepare for the next demo. Okay, so wrap up. This time we started from the API specification. Both provider and consumer implemented their API in parallel, but we still have the synchronization point where we need to deploy API consumer after the provider. And in order to test, we need either API provider being deployed first and then consumer doing integration tests, or we might do some mocking in order to speed up things on the consumer side. So this sounds good, but there is kind of a catch, right? Our system is kind of a system which serves a user experience, right? So we have a web application, and that web application serves the end users, and maybe the consumer has like a better knowledge about what the system should be capable of, right? And in this case, what happens is that API provider dictates, okay, this is my capability, this is what you can do with your API, and dear consumer, please integrate my API. And then a second aspect is that OpenAPI specification doesn't address too much the needs of the business logic, right? So it rather defines, okay, the API endpoints, what are the requests and responses, how your schema would look like. But for example, we have the example of our query parameters, right? So we want to provide a title and receive our recipes only with that title, or we want to get high protein or low calorie recipes, and the question is if API implements this business logic in a form of, and or criteria and so on. So it might be that consumer might expect some predefined behavior from the API provider, and there is a way to achieve that. So we could turn the process the other way around, and we could start with the API consumer driving the process, right? And there is a tool called Pact. So it's a code-first consumer contract testing tool that helps to start the process based on the consumer needs, right? And the process would like as follows. So API consumer would implement the contract in a form of unit test. That unit test would generate a contract. That contract would be published, and API provider would verify if its implementation kind of respects the consumer needs. And the following demo that I will show would be based on Pact, and yeah, let's start with it. Okay, so in order to be able to exchange the contracts when using Pact, there are two options, right? So you can generate Pact and share it as an artifact. But also Pact provides a tool called Pact Broker, where it can be used as a middleware to exchange the pacts, and it provides a nice way to verify that pact has been achieved, has been verified, it is deployed, and you can also do the checks if you are allowed to deploy and so on. And I already configured Pact on my local before the demo, right? So this is how it looks like. It has a UI that you can observe the pacts. Then when I go back to my consumer first example, we could already observe how the process starts from the client, right? So as I told, we implement our pacts in a form of contract test. And for that, Pact provides a nice JUnit extensions, which helps you to build the Pact. So I declare the Pact consumer test. I define that I'm building the Pact for the recipes provider, right? Then I have the interactions where I define the behavior so the supposed behavior of the API, right? For example, I have 3 expected interactions, right? So the first one is that I, as a consumer, am instructing the provider upon receiving get all recipes requests to the path recipes, to the recipes path through get endpoint to respond with status 200. And the response body structure should look like given here. And you can have a nice DSL to achieve that, and that would already create the contract for you. The first example, as I showed, is without any query parameters. Then we have the second example. We use the builder and we instruct the provider, dear provider, when you receive the get pumpkin recipes to the path recipes with the title pumpkin with method get, you should respond with status 200 with the recipes response structure which contains pumpkin only, right? So this is where I have expected behavior. And then the third one is, dear provider, when I send you the get low calorie and high protein recipes with these query parameters, I expect that you send only low calorie and high protein results to me. And then this is the declaration of Pact, but of course we need to write some tests for those Pacts. So I have 3 tests for these Pacts. What is nice about the JUnit 5 extension of the Pact is that it injects a mock server to my test, which provides the predefined behavior of the server as a mock, right? So then with that mock that is given to me, I could inject the URL that is given, and then I could create my controller with the recipes API with the URL that Pact mocked gives to me. And then here I am kind of testing my own application, and my server side is mocked based on my expectations, based on the interactions that I provided. So now when I run the tests, I should also do some assertions to test things internally, right? And I'm repeating that for my 3 interactions, and then I can run my test, and we can see that my test generates a contract. It is found under build folder Pact. It is a JSON, which as I said, could be exchanged as an artifact, but in this case, I am using the tool, the medium called Pact Broker, in order to communicate it to the provider, right? So my next step would be publishing my Pact. And when I publish my Pact, I could go back to my Pact Broker and see that there is an interaction submitted there. So the interaction is between recipes client and recipes API. It was published less than a minute ago, which I did, but not verified yet. So now it's provider's turn to verify it and make sure that it has fulfilled the Pact. Going back to my consumer first implementation, I could already show how it looks like. So the actual implementation is my classic consumer first application with the controller, right? So I have implemented my controller. This time it's code based, it's not generated. Then I have my test. My test this time uses a JUnit extension, a JUnit 5 extensions, which is built for Spring Boot, right? And I'm defining a couple of things. So I am saying this is a Spring Boot test. I'm the provider recipes API. I communicate with the Pact Broker. So whenever I run my test will pull the contract. And will trigger the necessary test. So here I have some extension declarations where JUnit 5 extensions would inject the Pact interactions into my application. And my test would simply replay the interactions of the Pact to test that my API implementation is correct, is based on the interactions that are expected by the client, right? So let's run and see if my API behaves as expected. So I have one failing test, and that shows that I didn't implement the API based on consumers' expectations. So we can see what's wrong, right? So I have a verification which indicates that I was expecting low calorie and high protein, but I received some other results. So that means that my search doesn't apply the right criteria. And I will go and fix it. You can already see I broke it because it's a demo, so I need to show that verification is being done. So now I could repeat my test, and I will see that now everything works fine. And now we have the Pact achieved, but consumer is not informed yet. So consumer needs to know, and again, we do that through the Pact broker. And in order to achieve that, we have our next step, which is first deploying the application and making the consumer aware that we have deployed the application, so you can go next and you can deploy your application. So then we will do that. So we will deploy our service. Our service is running, right? And now we can use this Gradle task, which does the Pact verify, but also publishes the verification results and informs the Pact broker that the verification has been done. Now going back to the Pact, we can see that this interaction between recipes client and recipes API has been fulfilled, meaning that Pact has been achieved, and now client is free to go. So client can deploy the application, and both of them would be kind of syncing in their development process. And one way to achieve it is implementing some webhooks where you would notify the consumer. Another way is client doing some checks before deploying, right? So we could try to do that. This is my consumer first application. So my last step is a Gradle task called "Can I deploy?" right? And the Pact says, yes, you can deploy, you are free to go. So in this case, Pact is not only a consumer contract testing tool, but it provides ways to sync when a provider should deploy things, when it should inform that it has deployed, and when a client could go next. And yeah, this is, in my opinion, quite a nice feature. So when I talked to a developer, when I talked with someone who is using Pact, they also informed that he kind of said they are using in their continuous deployment process, where they are aware if they are breaking anything before deploying any application to the production. So this is quite useful approach, right? So yeah, we're almost done, but I have one more use case. So now that we managed to build a consumer first approach, we actually lost two things, right? So yes, we found a way to test two applications independently, right? And then we found a way to fulfill the expectations of the consumer, but we are missing now the common language, right? So initially we started with the claim that the common language helps, and OpenAPI specification is the common language. It is not the Pact, right? And then we also lost the feature where we can generate code. So when we use Pact, it's a code-first approach, and we maybe would like to still use OpenAPI specification. And even though consumer first and API first might sound contradicting, actually there is a way to combine both approaches, and that can be achieved. By validating the generated contract against an OpenAPI specification. So I have a small example for that, which I would like to show. Right, so I disabled because I didn't want it to interfere with my original test, right? So my Pact consumer test has the same Pacts which I showed in the previous example. This time I'm using a third-party library which is called Swagger Validator. So Swagger Validator kind of provides tools which could be used to validate things against OpenAPI specification, right? And one of the features that it provides is verifying your generated Pact against an OpenAPI specification, right? So we declare it with a builder DSL style, and we say, okay, create my validator from the specification URL, which is my recipes API YAML. In this example, I'm using the API specification which I pushed to GitHub, but it could be used from any local file or any other solution. And this would ensure that the consumer does not define any expectation that is beyond provider's capability, right? For example, I could define a Pact that doesn't make sense, right? For instance, I want a recipe which has the nutrition facts of high alcohol, right? And I could say get recipes by high alcohol. This is a Pact, right? And then I could say, again, I want the result to contain high alcohol. And this is the Pact part, so I need to implement the test. And I would implement the test which tests the interaction with the new Pact. So get recipes with high alcohol. So let me make sure I copy paste the right one. So now I'm referencing the new Pact. I'm also setting up the expectation of high alcohol in my interactions, and let's see if our validator would let us do this. So you can already see that my validator ensures that we don't claim any value that is not supported by the specification itself. And then with this, we are kind of complementing the two approaches, right? So we are doing this bidirectional testing where consumer defines its behaviors, also provider uses the common language. We can use the generated clients. We can generate code, and we can test things. In parallel. So it kind of it kind of gives a complete solution and also gives, you know, a nice way of communicating. And with that, we are done with the demo. So so now I tried to, you know, there is no decision tree, but there are some hints that could be used to decide which methodology to use, right? So again, if you are trying to focus on coding and if you want the flexibility to change the API, then you could use the code first. Or let's say if you want to prioritize your API design, if you want to generate documentation quite early, if you want to use code generation on the server side, or if you have a large number of consumers, then you might use API first in this case. Or in my past experience, I also used the approach where on a new project, I started with the code first, and then once my API was stable enough, then I switched to API first, and then I kind of established a process and so on. And then consumer first could be used, you know, for the use cases where you need to test client and server independently. You might want to sync the deployment process. One thing that doesn't work well with consumer first is that you can work only with one or two consumers, but if you have a large number of consumers, then they might be conflicting expectations from multiple consumers. So it works out if, let's say, you start with one client, and then once you introduce multi-tenancy or things like that, then you might need to change your approach, or you keep trusting your best consumer, and yeah, you can keep working on it. And then, as I said, you can complement the approaches with each other, and yeah, I mean, you could use this bidirectional approach where you use both consumer first or API first. I mean, I will skip this fast. So you could use the same approaches with AsyncAPI because it is inspired by OpenAPI. You can do code first, API first. Pact supports messaging, and again, you can have a look on the tooling that AsyncAPI supports. Initially, we talked that documentation was the most burning part in the survey I shared, right? And I shared that 50% of the consumers are having troubles on finding the necessary API documentation. And actually, I must say, I don't have a success story or best practices of this, so I'm also one of these 50% people which had this kind of challenges. And yeah, it made me think, so what I was doing wrong, right? So, for example, there are, I mean, API specifications could be used to leverage, could be leveraged to generate more human-readable forms of API references, right? So, but always in my past experience, I had troubles, you know, convincing maybe product owners or convincing technical writers that there's the generated documentation. Why don't you use it? And there was always a gap. So one of the things that made it worse was serving the generated documentation with the application together, because I've worked in fintechs for long years, and when you work on fintech, you always have these firewalls and not being able to access your application, and then you don't have access also to your documentation, right? So one thing I learned through this process was generating an API specification and the documentation, and maybe hosting it somewhere else, you know? So if you have GitHub, it could be a GitHub pages. And then if you have, I don't know, a developer portal, if you're using Backstage can do that. Or if you are using, I don't know, any wiki like Confluence, then find the right API to be able to publish your generated documentation there, so that you are using the same tool with your product owner or other people that are using. And then, of course, if you are having OpenAPI, if you are having API documentation, one thing to pay attention is that Swagger is not an API documentation, so it's rather an API reference. And API documentation is usually a page written by technical writers that incorporates conceptual technical information together with the generated API reference, which could be maybe embedded to it, and yeah, it makes sense to do it continuously, because if you are doing once, it can diverge and yeah, it might not fill the purpose. But anyway, based on my learnings, in future, if I get another chance to do it right, this would be the approach that I would try. And yeah, that would be some lessons learned which I couldn't apply yet. And recap, yeah. So we said we could enhance API discovery by using common language, right? So we have OpenAPI, AsyncAPI there. Then we have the right methodology for the right use case. So code first, API first, consumer first, or we can mix them. Then there are some tools to speed up the development, like OpenAPI generator to generate code or documentation. There is Pact for contract testing. There is Swagger validator to validate things. And last but not least, API specification could be used to generate API reference and could be used to generate API docs on a bigger scope. And if this is done continuously, then it helps. With that, I end up my presentation. So if you want to see my slides, to reach my examples, I'm sharing them, and I hope there is something that you can take home and yeah, have a look later on. So thank you for listening. So I don't know, do we have time for the questions? Any questions?
In your last slide, you talked about mixing methodologies. Do you have an example or where it makes sense?
So in my example, I used high alcohol, right? So OpenAPI. So let's say you might define your features on your OpenAPI specifications, like my nutrition fact is an enum, right? So high alcohol, low calorie, low calorie, and so on. Probably I need alcohol now. So if, let's say, you define the capabilities in a form of enums in your OpenAPI specification, then you could keep the control of what consumer expects on. And I guess this is one of the ways. And then others could be, maybe consumer expects something like an integer where in fact you are supposed to return a string, or other way around. And you should make sure that consumer has the right expectation, doesn't expect the wrong format, and it makes sure that it also follows some semantics of your schema. Did it help? Yep.
So first of all, this was great, thank you. In the last topic, in the consumer first, would it be okay, or what would happen if the provider goes ahead and extends the API by adding new endpoints and keeping the contract as it is with the current consumer, or just keep adding?
If it is, so how it works is that the contract is replayed on the server side during the testing, right? So in fact, you are testing what consumer expected from you. But if you do more, I guess that is kind of out of scope, right? So it shouldn't fail. I didn't try it, but it shouldn't fail your test. So you can actually add other features to your API. What's important is still to fulfill the expectations.
The consumer first kind of has a high coupling in this case.
Mm-hmm. I wouldn't say it's a high coupling. I mean, yeah, it kind of couples the provider to the consumer, right? Because you are supposed to do the implementation based on the contract that consumer gives to you. But I mean, what could happen is that you implement a feature on the API which is not covered by a consumer yet, and then consumer suddenly starts defining this expected behavior, and then it conflicts with your existing feature and so on. So yeah, in that case, it's not a silver bullet. That involves communication and strictly to follow your process. If you strictly follow your process, I guess there's nothing to break there.
But I would say that if the provider keeps enriching, then probably the provider is doing more than it was supposed to do. So it's like it loses the original purpose it was created. Maybe that's why it might not be a good idea.
Yeah, I mean,
that's doing code first again, you know?
Yeah.
Or flavors, right? So some standard, it's mix and match then.
Yeah. So I mean, bidirectional. I think for me, it's a silver bullet, which ensures best side of both worlds. But it's also, you know, if you have a simple use case and using that much control, then might also backfire. You know, depends on the use case. Thank you. Any other question?
What about supporting multiple versions for Pact? For example, if a client publishes Pact, it's implemented by server, and another client start also using this, and first client decided to change. So should the system automatically create new one, or?
Once you published a Pact, that is immutable. You cannot publish the same interaction with the same version anymore, right? So the next iteration should be recipes client publishing 002 snapshot in this case, right? And I mean, it is kind of idempotent if you don't change anything. So you can publish the same one, but if you change the Pact and try to publish again, the Pact broker would block that for you.
But does it allow to change snapshot at least before, or like in fixed reads or something?
It allows. I mean, this is the simple version. So there are also features by Pact where you can where provider could declare itself that it has deployed its verified application to the production, right? And until you have deployed it to production, you can change that. But I mean, for this, I recommend having a look on the Pact documentation. So this concept is described there. So as I said, this is very simple. But there is another flavor where you declare where provider says I deployed it, and once you deploy it, doesn't matter if it is snapshot or whatever, you cannot change anymore. I cannot cover your expectation. Any other? Yep.
And do you know there's a different, you can write your Pact in different languages, like for example if you have a React client or something, or Angular, that you can define it in TypeScript and then verify it against the provider as well?
Yeah, I know it has extensive feature, but we are on a Java user group meetup, so so I presume.
How many people are still in the Java front end part?
Yeah. I mean, also the front end, I picked a Java one, timely, but it's not very, how to say, I usually use Angular, React, Vue, whatever, right? And thanks. So nice questions, and sorry for the hiccup.